Oh, hello. Welcome back for our junior session. So welcome to the ASV Junior live stream event. Today we are joined by ASV Junior Section Director Chris Rudge and ASV Junior member Sadie. Sadie and I will be presenting a talk on how galaxies are made, and Chris will be discussing our junior program and answering all of your questions. So if you have any questions, please put them in the comments section. But for now, I'll pass it over to Chris to give us a bit of an explanation about what ASV Juniors is all about.
Well, good afternoon, ladies and gentlemen. Our junior section, the ASV Junior section, is for young adults, young children from 6 to 16. We make it from 6 so that the children can take notes and are prepared to sort of sit there and listen to a talk on various subjects to do with astronomy. So we look at the basics, how to find your way around the sky, most importantly. Distance, how big is space, the universe, how big the universe really is. Types of telescopes, stuff that Perry went through last night, put perhaps slightly differently. One of the favourite topics is always black holes. I've had some extremely animated discussions about black holes. Life cycle of the stars, their birth and their death. How atoms are formed in the stars. I'm sure you may have heard of the quotation, "We're all made of star stuff." Well, we take the juniors through and show them all the different atoms, how they're made, how they're forged in the stars. And we also talk about planets, all the way through from Mercury right out to Pluto and beyond. So during my time as director of the juniors, about 7 or 8 years, we've carried out numbers of projects. And one of the first was to image an exoplanet actually going around its star. And that was Corot 2 in Aquila. We also imaged an Einstein ring. That's where one star is way beyond a galaxy, or another galaxy is right behind another one, and you actually use the lensing effect of the forward galaxy to see one much, much further away. We've had one young man who's just left us. He discovered an unknown variable star and a double star, and he now has the credit of those there in his name as the discoverer. We had one young lady who won the BHP National Prize, and she worked with Russ and put forward a number of images of the solar of the sun. She was also on national TV with Brian Cox some time ago, and he said of her, wow, he said, that's my next PhD student. We've also had one young man who's controlled the dish, and that's the famous dish at Parkes. And the other night he was actually privileged enough to control the AAO telescope at Siding Springs. There are enormous opportunities for all our young people if they're prepared to grab them. Obviously, currently we can't meet in person, so we're meeting on Zoom. And this has obvious good effects. It cuts out travel time for a lot of people and allows some of our more remote juniors to come in without their parents driving them an hour or so each way. Even when these COVID restrictions are lifting, I think we'll still be continuing with Zoom to allow this to happen with our country members, so that we become more the Astronomical Society of Victoria rather than all Melbourne based. So I think that's a reasonable overview of what we do, and I'll now pass you back to Mark and Sadie.
Okay, so I'm trying to, here we go. I need to share our screen, Sadie, so that we can do your presentation. All right. Can you see that, Chris?
I can.
Beautiful. Can you see all of us?
Yes.
Yep, that's exactly what we want to see. Okay. Now, Sadie, would you like to do your introduction?
Yes. Hi, I'm Sadie and I'm 7 years old and I'm in grade 2. I've been doing astronomy since I was 2 years old because of my big brother's interest in learning about space. We've been going to this place called the Leon Mao Dark Sky Site where they have really big telescopes you can look through. I like looking at Saturn and Jupiter and the Tarantula Nebula. Whilst I've been doing remote learning during lockdown, I did a project on galaxies. With the help of Chris Rudge, the director of ASB Junior Section, we've expanded my project to share with you today. Hope you enjoy it.
All right. So what's it called?
Galaxies and how do they form?
Okay, so first slide for you.
We live on a planet called Earth. Earth is part of our solar system, but where is our solar system? It's a small part of the Milky Way galaxy. The Milky Way measures 100,000 to 120,000 light years in diameter. It is about 1,000 light years thick and contains about 400 billion stars. The solar system and Earth is located about 25,000 light years to the galactic center of 25,000 light years away from the rim. It takes the Sun 250 million years to complete one rotation around the Milky Way. This is what we know as a galactic year or a cosmic year. The last time the solar system was in this position in the Milky Way, there were dinosaurs on Earth. There are many galaxies beside ours, though. There are so many we can't even count them all yet.
So, how are galaxies made? Although the formation of galaxies is not fully understood, astronomers have been able to identify for three key processes that are involved. There's a primordial collapse, which is the collapse of an individual gas clouds early in the history of the universe. Hierarchical clustering, which is the formation of large galaxies through the merging of many smaller ones. And secular evolution, which is the formation as a result of internal processes such as the actions of spiral arms and bars.
Black holes. Astronomers believe supermassive black holes lie at the center of all large galaxies, even our own Milky Way. But what is a black hole? Imagine a star 10 times more massive than the Sun. Then imagine it squeezed into a sphere, approximately the diameter of Melbourne. The result of a gravitational field that is so strong that not even light is able to escape it. Most black holes are formed from the remnants of a large star that die in a supernova explosion. What types of galaxies are there? In the 1920s, astronomer Edwin Hubble discovered that the Andromeda Nebula was in fact a galaxy. Andromeda Galaxy is so far from us that it takes more than 2.5 million years for its light to bridge the gap. Despite the immense distance, Andromeda is the closest large galaxy to our Milky Way. Andromeda Galaxy is bright enough in the night sky that is visible to the naked eye if you know where to look. This is a hard task in the southern hemisphere, but it's still possible from certain locations under the bright sky conditions away from city lights. In 1936, Hubble introduced a way to classify galaxies, grouping them into four main types: spiral galaxies, lenticular galaxies, elliptical galaxies, and irregular galaxies. Let's take a look at these types of galaxies in more detail.
Oh, spiral galaxies. More than 2/3 of all observed galaxies are spiral galaxies. A spiral galaxy has a flat, spinning disk with a central bulge surrounded by spiral arms. That spinning motion at speeds of hundreds of kilometers a second may cause matter in the disk to take on a distinctive spiral shape like a cosmic pinwheel. Our Milky Way, like other spiral galaxies, has a linear starry bar at its center.
Elliptical galaxies. Elliptical galaxies are shaped as their name suggests. They are generally round but can stretch longer along one axis than along the other, so much that it can take on a cigar-like appearance. The universe's largest known galaxies are giant elliptical galaxies. Giant elliptical galaxies can contain up to 1 trillion stars and span 2 million light years across. Elliptical galaxies may also be small, in which case they are called dwarf elliptical galaxies.
Ooh.
Lenticular galaxies. Lenticular galaxies, such as the Sombrero Galaxy, sit between elliptical and spiral galaxies. They're called lenticular because they resemble lenses. Like spiral galaxies, they have a thin rotating disk of stars and a central bulge, but they don't have spiral arms. Like elliptical galaxies, they have little dust and interstellar matter, and they seem to form more often in densely populated regions of space. Irregular galaxies. Galaxies that are not spiral, lenticular, or elliptical are called irregular galaxies. Irregular galaxies such as the Large and Small Magellanic Clouds that flank our Milky Way appear misshapen and lack a distinctive form. This is because they were within gravitational inflows of other galaxies close by. They are full of gas and dust, which makes them great nurseries for forming new stars.
Oh, how many galaxies are there? Well, the Hubble telescope once looked at a small patch of space for about 12 days and found 10,000 galaxies of all sizes, shapes, and colors. So how many galaxies are there out there, and can we count them all? Hubble's work in imaging galaxies has revealed an estimated 100 billion galaxies in the universe. However, this number is likely to increase to about 200 billion as our telescope technology in space improves. As the universe gets older and bigger, galaxies will begin to move farther away from Earth. This will make them more difficult for us to see and count in telescopes. As we're only able to see galaxies whose light has reached us, it becomes harder to know how many more might be out there whose light has simply not reached us yet. So that is Sadie's presentation on galaxies. Do we have any questions? Let's have a look. So
Fantastic, Sadie. Very well done.
So, what are you doing? What are you up to? Sadie's having a look at the comments. Do we have any questions from any of the junior members out there? Or even the adult members? Oh, hang on, we have a question. Poppy Brown, Chris, wants to know, why only large galaxies? Why not small galaxies?
Well, they vary in size in their clusters of stars. Often the small galaxies get gobbled up by the big galaxies. And if you probably look at the Large and Small Magellanic Clouds, they're satellite galaxies of our Milky Way, and they're gradually getting dragged into it. And galaxies, by their nature, tend to be large objects and contain many millions of stars. Now, the interesting thing is that we say that they've all got a large black hole in the middle. We're not sure whether it's a bit like the chicken and the egg. We're not sure whether the large black hole caused the galaxies to form or the large black holes were caused by the galaxies. So there's an awful lot out there that we simply don't know yet. And we're waiting for the next generation of bright young astronomers to come along and prove some of these things. There's huge opportunities there for people.
Okay, so we have another question. Millie asks, did Edwin Hubble make the Hubble telescope? Sadie, can you answer that one? Did he? Did he make it? No, he didn't make it, did he, Chris?
No, he didn't. It was named after him. It was named after him in his honour.
There you go. Now, we have, what have we got? How old is our galaxy? How old is our galaxy?
I feel like 200 million.
200 million years old? How old is our galaxy,
I
Chris?
feel like 200 million years or 2,000.
Billion.
Billion.
Earth is 4.6 billion, and we're a third generation star. So the universe is thought to be about 13.7 or 8 billion years old. We lay somewhere in there, and I'm not sure that that's a question that we can really answer at the moment.
No, I don't think we can.
Not one of the first ones. So it would be, as we said earlier, the sun is about a third generation star. So it would be maybe 8-10 billion years old.
There you go. All right.
Maybe.
Sadie, which is your favourite galaxy?
Tarantula Nebula.
No, that's a nebula. What's your favourite galaxy?
My favorite galaxy. Probably Andromeda.
Andromeda. I like sombrero because it's like a hat. Okay, so we have another question. How many solar systems in our galaxy, Chris?
Well, up until very recently, and I really do mean very recently, like in the mid-1990s, we thought we were pretty unique. Now the thinking is that the majority of stars would have a solar system, or more precisely a planetary system around them. The solar system refers directly to our sun, but yet a planetary system are the planets going around another star, and we think that the majority of stars would have a planetary system.
And we have a lot of stars in the galaxy.
A lot.
A lot. So have we got any more questions? Anybody else got any questions I would like to ask about galaxies, or even about, it doesn't necessarily have to be about galaxies, does it, Chris? It could be about planets. It could be about the solar system. It could be about stars. It could be about nebula, like Tarantula Nebula. So let's see if we've got any more questions. Neil said that your choice of Andromeda was a good choice. What's your favourite galaxy, Chris?
Well, it's got to be the Milky Way, our own home galaxy, I think. And I love Sadie's depiction of it with some milk and a road. Superb.
Yeah, that's good.
Because it's the Milky Way.
It is. Yeah, yes.
And in the distant future, Andromeda is coming towards us. We're actually going to merge with the Andromeda galaxy and make some huge big galaxy, and they're talking about calling it Milkomedia. So don't worry about it, guys. It's several billion years into the future.
Okay, we have another
coming towards us, and we tell that because it's got the light coming towards us is blue shifted rather than red shifted, which means things are going away from us.
So if the sun is a third generation star, does that mean that when it dies, there'll be one to replace it?
There will be other stars, but it won't be replaced as such. It will end up as a white dwarf in the middle of the system of what's left of it after the sun has turned into a red giant. It will expand as it gets older. It will go red, quite red, and it will probably expand out that Earth and Mars will be travelling through the outer layers of the sun. So it won't be very nice. However, don't really worry about it because it is several million, if not a billion years in the future. So it is time in astronomy is very long. A year is a very short time. While we measure in years, most of things like the life of stars is measured in millions of years.
Okay, so we've got I've got another one here for Sadie from Kitty Cat. Sadie, what is the difference between a galaxy and a nebula?
Well, a nebula is a cloud of dust and gas, usually tens to hundreds of light years across. A galaxy is much larger, usually thousands to hundreds of thousands of light years across. Nebula are one of the many things that galaxies are made of, along with stars, black holes, cosmic dust, dark matter, and much more.
Oh, good answer. Okay, so Chris, one for you. Michael has asked, how far away is the moon from Earth?
Oh, yes. Off the top of my head, I think it's about 300,000 kilometres.
Give or take?
Give or take.
Give or take.
It's got a slightly elliptical orbit, so it can come closer and it can go further out.
Okay, so why was Pluto renamed a dwarf planet, and what is the difference?
Okay, that's a fairly technical one, and the international IAU, the International Astronomy Union, decided that Pluto would be demoted or changed to a dwarf planet. They found several other planets out further, and they were just concerned that we were going to keep adding and adding and adding planets. So they made a new category for Pluto and others, and they called them dwarf planets. Pluto is actually smaller than our moon, so it is a fairly small object. It's also a very interesting object because with its main moon, they actually rotate round each other, and they rotate round a centre of gravity between the two of them, which is called the barycenter. So they are almost a dual planet. In fact, it would almost be the whole system of Pluto is way more interesting than we ever thought. So
there's lots of other little dwarf planets out there as well.
Yeah, Ceres, Makemac, and others way out in the Kuiper belt.
How many exoplanets have we found?
We found 4,000 exoplanets.
More than 4,000, I think over 4,000 now, but yes, that's a good starting point. Over 4,000 exoplanets.
That's today. Ask tomorrow, it'll be a larger number.
Every day there's more added. Sadie, what is your favourite planet?
Saturn.
Saturn. Why?
Because I like its rings.
You like its rings. All right, Chris, here's one for you.
One of the prettiest planets in the solar system.
Beautiful to look at. What are the nearest and furthest galaxies?
Ooh.
Aside, not including our own, obviously.
I think we'd probably come up with Andromeda for one of the closer galaxies. And the furthest galaxy, we're finding further ones out all the time. There was one found a little while ago right out close to the edge of our known universe, which formed very, very soon after the Big Bang. So it's a long way out. Yes.
Oh, we've got some troublemakers in here, Chris. Nearly saying it's the Large Magellanic Cloud. I mean, there's also here's a question: are the Magellanic Clouds really galaxies?
Uh,
I
I
mean,
guess that would depend on your definition. You would have to define a galaxy fairly closely before you can do that. Are they really galaxies? Probably not. I don't believe that we've found a large black hole in the middle of them. Again, these things almost change day by day.
that is true. Okay, so we have another question from Poppy Brown. Are there other dwarf planets mentioned in our solar system or outside of it, Sadie?
I can do this.
Yeah?
There are no dwarf planets outside, they're only inside.
Is that correct, Chris?
I would say there's none that we've found.
There we go. So to this point, you're correct. There are none outside it at the moment. That's true.
There probably are, but we cannot see them. We only see the larger of the planets around other stars because of our instrumentation, because our telescopes and our techniques can't see them yet. When the James Webb telescope goes up, we might see some more planets, and we will start to see smaller planets.
All right. I think we're out of questions there, Chris. So, yes, you can go now. Say bye-bye.
Bye.
Bye.
Bye. Thank you, Sadie.
And she's off.
My legs.
She's off without it. That's it. So, have we got any other questions before we finish up our junior session? See if we got any more popping up there. Haven't got any more at the moment, but if you've got kids over the age of 6 that are interested in astronomy, Chris is an excellent teacher. He's very good with the kids, patient as well. So if you want to, you're allowed to come along. Once or twice, Chris? Once before just to see what it's like and see if they're interested.
We like the new members to come along, or potential members to come along, have a look, see what we do, see whether you like it. Raising kids is very expensive, so we give people the option of coming along a couple of times before we like to see them join up. We obviously want members, but as I say, it's expensive to raise kids. If they don't want to come and they don't like it, that's fine. It isn't for everybody. Those who come along thoroughly enjoy it. Maybe they stay for 2 or 3 years and move on, or stay right through. There are senior members that started off as juniors, and there's one in particular I'm thinking of. He's an excellent astrophotographer. And started off in the juniors, probably more years ago than he likes to admit. But there we go.
We've got a couple more questions. So I think from, if I remember right, my brain's working properly, we've got junior membership as well, which is $55.
Yes.
And there's no joining fee. So there you go, Eleanor. How much is membership for juniors? It's $55 with no joining fee. There is a residential membership, which is $110, and it's a $20 joining fee, and that gives everyone at your residence, everyone at the same address, access to the ASV, so adults and children alike.
Now, for our meetings, when we actually hold them face to face, we do expect the parents or a guardian to turn up.
Yes, that's definite.
A lot of the guardians get quite something from the talks too, didn't they, Mark?
Oh, they did. Yes, I mean, look at me now. If it wasn't for Blake getting interested in astronomy, I don't think I'd be here now doing this. So we blame him. Absolutely blame him. We've got a couple more questions. Kitty Cat wanted to know if Sadie wants to have a career in astronomy. We will ask her and get back to you. I know her brother does. Whether she does or not, we're not sure. She does keep talking about wanting to have a YouTube channel, so maybe that's where her astronomy skills will go. Now we've got some more questions, Chris. What defines the solar system?
It's the area, the volume of space which is controlled by the gravity of the sun. So that goes way, way out beyond Pluto. Way out beyond Pluto.
Okay, so could we ever travel to Andromeda? We don't have the equipment, that's for sure. Not even the SR-71 Blackbird can make it there quick enough.
If we, even with our current technology, to travel to the closest star is about 180,000 years. The closest star is four and a bit light years away. We're talking about millions of light years to get to Andromeda. So the chances of us getting there are extremely small. Until we find warp drive, of course.
Or wormholes, maybe. How many stars are there in the universe?
Wow. We think there are absolutely billions of universes. There are billions of galaxies, and there are millions, if not billions, of stars in each of those galaxies. So a simple mathematician multiplying the two together, and there are absolutely billions and billions. It would have to come under the heading of uncountable.
There you go. We've got a very good one here, Chris. Are the telescopes recommended last night also recommended for children starting off in astronomy? I can answer this one. That 8-inch Dobsonian is the first telescope my son Blake got. He got it for Christmas 5 years ago, thereabouts, somewhere 5 or 6, I'm not sure exactly. And that was his first telescope. And Chris mentioned earlier about one of the ASV juniors who moved Parkes radio telescope and moved the AAO telescope or AAT telescope the other night. That was my son Blake. So that's where he's gone. He started with an 8-inch Dobsonian, learnt about astronomy and using telescopes. He now has equipment that he uses in the backyard to image galaxies and nebula and star clusters. So they are the 8-inch Dobsonians. Perfect spot for kids to start, aren't they, Chris?
Yeah, anything much smaller, and you'll be looking, if you're serious, excuse me a moment. If you're serious, anything smaller than an 8-inch Dobsonian won't cut the mustard. You'll be looking to replace it, and there's no market for those small telescopes.
So I use the 8-inch now, even my moon photography that I muck around with in the backyard, and it's perfect for that as well.
I've started off with an 8-inch, and I've still got it.
And what have you got now?
It's more often used. I've got a 16-inch as well. As Perry said last night, we all suffer from aperture fever.
Yes. Once you get one, you want a bigger telescope. What have we got? If the solar system extent is much greater than Pluto, why are there no other planets in our solar system? And I'm assuming that would come down to a gravity issue, being too far away from the sun.
It goes out a lot further than Pluto.
There's talk of
Pluto.
There was talk of Planet X for a while, wasn't there?
They keep talking about the 9th planet being out there somewhere, but they've yet to see it. They were talking about another giant planet out there, but it's hiding itself fairly well if it is there. But when you get right out to the heliopause, it's a long way out. It's almost a third of the way out to the next star.
Sorry. So we have another one. Milan, who's 4, asks, is there another planet like Earth?
Not that we know about yet. It is one of these questions. There There are planets being found in what we call the Goldilocks zone. That's where water exists as water, ice, and vapor. So yes, there are planets gradually being discovered, not very many yet, in that zone. Is there another Earth out there? More than likely. We haven't really found it yet.
Sally got a question from Ella. So how big will the sun be when it explodes?
Our sun won't actually explode. It isn't big enough to explode. It will end up going to the red giant stage, and it'll slough off heaps and heaps of gas, which will show up as a nebula, as planetary nebula at some stage, and then the sun will shrink down to a white dwarf, and as it gradually cools down, it'll end up as a small black cinder lost in the blackness of space. But, as I said, don't worry about it. It is a long time in the future.
Okay. Hang on. Oh, Sadie, there was a question for you earlier, and I said I'd come back to it. Sadie, do you want to have a career in astronomy? And I said you probably wanted to have some sort of YouTube channel with sciencey stuff on it.
Well, I mean, I am doing a main YouTube channel for myself and then another YouTube channel for my for science and astronomy.
There you go. That's it. So you want to do science and astronomy
So
YouTube.
my other YouTube channel will be Princess Pie, science and astronomy with Princess Pie.
There you go. It's just fun. Okay, yes we do. Have we got any more questions come through at all? No? I don't think we have. I think we've run out of it. Chris, I think we've exhausted the questions. And I know I mentioned before about Blake and the stuff that he does, and it wouldn't have, without Chris's help, he wouldn't have been where he is. And he's, he tags off the ASV pretty well, and he has his own little Facebook page, Astro Blake, where he puts all of his stuff up that we sometimes share on the ASV Facebook as well. And we've got another question. Here we go. Samath, 5-year-old, asks, why can't we go to Uranus?
Why? It's a very, very long way away. I mean, at the moment, the moon, it takes us 3 days to travel to the moon. It will take us 3 months, 4 months to travel to Mars. To get to Uranus, it will take probably a couple of 3 years. And we simply don't have the technology at the moment to go that far. Maybe one day, but it'll be a fair way in the future. It'll take numbers of breakthroughs. We have to protect ourselves from the harsh radiation in space. And you've got to carry all your food. You've got to be able to manufacture the food. And the next question is, what would you do when you got there? Because you certainly couldn't land on it. You might be able to land on Titan, the moon, but you certainly would not land on Uranus or any of those other gas giants. They're moons, different kettle of fish. Some of those are rocky, some of them are icy, and some of them would be very interesting to land on.
Yes. All right. So we have one more question. Sophie, a 4-year-old, would like to know how the moons get in the sky.
Some of them are captured rocks. I mean, Jupiter has close to 80 moons that we know about. Many of those are just chunks of rock, maybe a kilometre or 2 in diameter, and they're probably irregular. The larger ones, how they get captured by the gravity of that planet. We think that our moon was caused by a collision between Earth and probably a Mars-sized object a huge collision, not huge amounts of, not a huge velocity difference between the two, but it was still a major collision. And the moon formed from rocks that were blasted out into space, and they gradually all got together and they reformed a sphere. There was enough of them to form a sphere.
Okay.
The moon at one stage was a lot closer. It is moving away from us gradually with time.
All
A
right.
few centimetres a year.
We've got another good question. How can I see Pluto with the telescope? It's not an easy task.
Not an easy task at all.
It can be done.
It is very dim. You've got to know exactly where to look, and then you have to go back over a number of nights to actually see whether you've to see its movement and to check that you've got the right object.
Yeah, you do. You got to keep looking. You got to essentially you need to jot down what you see, make a note of what you see, and then work out which one has moved, and then you go, "Oh, that was it. That's Pluto."
Yes, it was originally found with photographic plates. They took photographs of that piece of sky over a number of nights, a month or so, and then they held the two pieces, the two up, and they flicked between one and the other, and it's called a blink test. And you can actually see things moving across the plate. The majority of the stars were fixed, apart from this small speck of light that, I'm moving my finger, it went from one side to the other. And there was this, as you flick between the two images, you see the eye picks up something that actually moves. And that was all they could do back in 1936 when Tombaugh found it. These days we do much the same thing electronically with our electronic images.
Okay, so Hayden has asked, which planet is the most colourful?
I think that would have to be Jupiter,
I would
the
agree.
king of the planets.
Yeah, you think so? Mm-hmm. Yeah, Sadie agrees
What
as
do
well.
you think, Sadie?
I agree as well. It's Jupiter.
It's Jupiter. Yeah.
Yeah.
Yeah. We have another one here, Chris. We've got questions keep coming in for you. So Sienna wants to know, how many constellations are there that we can see from Earth, and can they also be seen from the moon?
There are 88 recognised constellations. Again, these are put out by the IAU, the International Astronomy Union, and yes, they can all be seen from the moon, and they would be much brighter and clearer from the moon because you're not looking through the Earth's atmosphere.
Wonderful. So what have we got? So apparently Earth has two moons. Why don't we hear about the second one?
We occasionally get an asteroid wandering into our path, and it might do a couple of laps around the Earth and then disappears. Nothing of any size will last between the Earth and the Moon. It will get flung out fairly quickly. So the second one, I think we're due to have one do a couple of laps around Earth and Moon very shortly. But we don't have a permanent second moon.
And we've got Luna, who's 6, wants to know, what is the biggest type of star? I think it's blue
giant. I think the biggest one we know at the moment is called the Pistol Star.
No, there is a Pistol Star. There is one bigger than the Pistol Star. I can't think of it off the top of my head. But yeah, there's one that's a lot bigger than the Pistol Star. So we'll have to come back to that one. We might do a post about that one on Facebook.
It is a blue giant, and it is 100. I think the Pistol Star is about 126 times bigger than the sun, our sun. I believe.
Let's go. Because I do remember. So the largest known star in the universe is UY Scuti, and it's 1,700 times larger than our sun.
Sorry.
It's big. We have another one. Here we go. Elouette, 5-year-old, asks, why do galaxies have planets? Well, galaxies don't have planets. Solar systems have planets, but why do solar systems have planets?
Well, yes, you're quite correct. The galaxies certainly don't have planets, but stars do have planets, and that comes back to their formation. A whole new subject. So I think you alluded to that earlier, Mark.
I did,
So
yeah.
there's a cloud of gas and dust, and probably a nearby supernova causes a shock wave, and it starts this mass of dust to start rotating. And as it rotates, it flattens out. The gravity draws it in to the star and to the central point. The gravity picks up and it gets more and more dust and gas come into the center, more hydrogen. When eventually it gets enough dust there and the temperature rises, think of when you use a compressor, when you blow up your bike tires, you'll find that the pump gets hot due to the compression. So as you compress more and more material towards the center, eventually it gets hot enough for atomic fusion to take place. Now, in the outer parts of the disk, there's a lot of extra material, and it starts to clump together, bigger and bigger, and the grains grow together and they clump together. Gravity starts affecting those, and it attracts more dust and gas until eventually you end up with a planetary system.
Yep.
We only see perhaps the largest of these planetary systems, and they have to be in a reasonable alignment to the Earth for us to actually see it.
That is true. So we have what makes a constellation a constellation?
We do.
We do.
Man decides.
Yeah.
Man decides that a certain number of stars make a particular pattern in the sky, and we very arbitrarily say, yes, that's the constellation of Orion, that's the constellation of Taurus, and we pick names for these things. Many of them are ancient names. People have laid back and looked at the stars since very early times. They've made up stories about a group of stars, and that becomes a constellation. The IAU come along and draw lines around it and say, this is Taurus, this is Orion, and so it goes on. But they are a man-made fabrication, if you wish.
They are indeed. We're being heckled by Astro Blake, Chris. In the comments.
Throw him an Oreo.
Yeah, he'd probably want Oreo ice cream. We have another one. Samarth again. Why is it very windy on Jupiter?
I guess it's like the weather on Earth. It's caused by pressure differences. We have huge storms on Jupiter. We look at the Great Red Spot, which is an enormous storm. It's been raging for 400 years that we know about. Jupiter itself rotates very quickly. I think it's an 8 to 10 hour day.
Yeah.
Some of the bands on Jupiter actually rotate quicker than others, and there would be friction there. Io whizzes round very close to it. That would stir things up. It's there's a lot of huge magnetic fields there. There's some very, it's a violent place. Huge magnetic storms. We actually listen in on something called Radio Jove, and you can actually hear the lightning crackling through the cloud tops.
We've got radio astronomy guys have got a Jove receiver, haven't they? They've got a Radio Jove at the Dark Sky site. Pretty sure it's still working. I think we haven't been up for a while. We keep getting asked about the second moon, what it's called. What is the name of Earth's second moon? It doesn't. We don't have one at the moment, but when it comes in, it's whatever it's been named. It's different each time, isn't it?
Yes, it isn't the same moon.
Never the same.
We don't really have a second moon at all. We capture the odd asteroid, as I say. It does a couple of laps around Earth, sometimes around Earth and Moon, and because the gravity is so strong between the two of them, it gets flung out. It won't last.
Michael wants to know how many dwarf planets are there in our solar system?
Oh,
lots. Probably too many.
I'll take that one on notice, but I'd say off the top of my head about 5 or 6.
There we go. And some that we haven't seen yet. If I found a random cluster of stars that don't belong to anything, can I call it a constellation?
No, you can call it an asterism, and you can find your own little picture in the sky of a number of stars, and you can call it an asterism. One of the asterisms that we see is when you look at Orion from our vision, you see a saucepan, and you see Betelgeuse under it, the flame making the saucepan boil. However, in the northern hemisphere, they see Orion as a warrior, but he's upside down to us. So the asterism that we see is the saucepan. The people in the northern hemisphere wouldn't see it that way at all. But there's nothing to stop you finding a group of stars and saying that looks like a whatever you think it looks like, and call it that. But the official ones by the IAU, I think, are 88 of them.
All right. I've got a good one for you here, Chris. Close the window. While you close the window, I've got a really good one that probably have to last. 3 more questions, and then we'll pack it up. We're coming to the end of our hour. So, what is a neutron star? Always good to see a 6-year-old asking a question like that.
Okay, a neutron star is caused by the collapse of a normal star, and it collapses into itself, and the normal star will consist of protons and electrons, and this star collapses into itself. The electrons are basically forced into the proton. It becomes a neutron. It becomes very, very dense, very hot, and they spin like crazy because they're very small. You have the angular momentum retained. As it goes smaller, it spins faster. So that is a very quick, rough and dirty explanation of a neutron star. A neutron star, a teaspoonful of neutron star material would weigh an awful lot.
We have some AC senior members, Chris, trying to trip you up with some questions here.
Oh, right.
Marcus, does Jupiter have a surface?
No.
There we go. And Jenny Painter, so why does Jupiter have so many moons?
Because it's got an awful lot of gravity.
There you
It's
go.
a very, very large object, and it pulls in many moons. I think 80, but it's there. 78, I think, is the latest number.
Something like that, yeah.
Saturn has even more. That's just taking the crown.
Yeah. So, one last question here. I think it's actually a good one too. What is the difference between a comet, an asteroid, and a meteor?
Okay, a comet is something that usually comes in from the outer reaches of the solar system on a very elliptical orbit, a very long, skinny orbit, and it contains gas and dust. As it becomes closer to the sun, the gas and dust boils off and goes out into space, and it ends up with a tail. An asteroid is basically a chunk of rock in an orbit around the sun, a small chunk of rock. A meteor is probably one of those asteroids coming in from outer space, burning up in the atmosphere. We also get some of the dust from the comets, comes in, crosses our orbit, and burns up in the atmosphere.
Right. Yep. Get back to us. All right, so I got two more for you, Chris, because these ones are killers. How do you measure the power of a black hole, and what happens if something gets sucked into one? Spaghettification.
We don't measure the power of a black hole. We measure its mass, and we look at its mass by the way stars actually orbit that black hole. Now, we've got a number of stars. If you look at the center of our galaxy, the numbers of stars that are actually orbiting that black hole, and they orbit it close, and they orbit very, very quickly. Now, if something gets sucked into one, there's an awful lot of speculation going on here because we don't really know. We don't have the physics to cover it. Physics stops at about the what's the word I'm looking for? The help me out.
On a mind blank at the event.
We've got both gone blank.
That's the point
the
of
event horizon.
Yeah,
our physics basically stops at the event horizon.
We don't know past that point,
which is part of the black hole. Once you get to the event horizon, you will go into the black hole. Whatever gets there goes into the black hole, and physics as we know it finishes and something else takes over.
It does. Yes.
There's one rather interesting point that if you go outside of the black hole, outside of the event horizon, and I don't think you'd even want to go this close, a particular distance from the event horizon, and you looked around the black hole with a large enough telescope, you would eventually see the back of your head.
Yep.
Looking at the front, the light would be bent around the black hole and come back, and you'd be looking at the back of your head. I think it's a third of the distance, 2/3 of the distance outside of the black hole. This is all put forward.
It escapes me at the moment, and I used to know it, and for some reason I can't recall it, but it does that specific point has a specific name for what you're talking about.
Yeah.
I think last one is for the last one here we got. Could Earth's gravity increase and decrease?
No, it's fairly fixed. Its mass would have to change massively. The mass of the Earth would have to change an awful lot to change gravity. It's it is what it is because of the mass of the Earth. So we gain a few tons per year of space dust, as we go through space. Meteors and dust, we pick it up. But we don't pick up enough to change gravity.
There we
The
go.
rate of gravity.
Wonderful. All right. Well, thank you everybody for tuning in today, and thank you, Chris and Sadie, for joining us for this stream. So we're gonna have a short break now, and we will be back at, I think it's, I should know this. I help put the thing together. Around about 7:30 for our live stream session. Actually, it's 8 o'clock for our live stream session of the Moon, International Observe the Moon Night tonight, and we'll also be doing, following on from that, we'll have a deep sky presentation where we'll be looking at galaxies, planets, galaxies, nebula, star clusters, live streamed into your homes. So come back and join us at about just before 8 o'clock. We'll also be drawing our second raffle as well. Thanks.
Thank you for joining us, and I hope you all learnt something.
See you later.
Bye. Bye.